Now, for the last example to illustrate MOD, we are going to look at a more typical question which is more likely to come out in an examination. So example 9. We are first asked to show some form, right, that is two fractions can be simplified into this single fraction and hence prove a statement on a series. So without further hesitation, let's dive into this. Now, for the showing part, we can either start from the left hand side or the right hand side, but as the left hand side is going to give me more room for manipulation, I would elect to start from the left. Okay, so intuitively I would first collapse the two fractions into a single fraction by making it to a common denominator. At this point, observe that my denominator is of the form that I want to show, so I'm not likely to change the denominator much. Instead, I would simply do an expansion, simplification, and easily I have shown what I'm asked to show. Okay. Now, hence prove that for n greater than or equals to 2, this formula holds. So let's take a look at this. This is very complicated expression, right? But it looks kind of familiar if you look at the row just above it. Is in fact the same expression, and because this is a hence question, I expect that I would need to make use of my answer from the previous part. So what I observe is I have just shown that this sum over here in blue with this star is actually equals to this. So I'm going to do a substitution, and now in fact this is suitable for MOD. I have two terms in similar form. Okay, they are both fractions, something square over a number, something square over a number, and I also have my sigma notation. So I suspect that I'll be able to do MOD. So now, without walking you through too much, I'm just going to show you the method of difference. Along with the cancellations. Okay, the cancellation in this case is relatively straightforward. We would just cancel it one row down. So cancel, cancel. Okay, so the terms that we are left with would basically be this term and this term. Sorry about that. Which upon simplification will give me this over here. And on further simplification, I find that I am able to show just what I want. Okay, over here all I've done is put it to single denominator. Okay, and after that it's just a matter of expansion and simplification. So before I round up today's lecture, once again, let's just do a quick recap of the important points to note for this method of difference. Okay, so for method of difference, to apply, firstly, difference of two similar terms. Secondly, it must be a sum. Okay, and when it comes to presentation, please note that first of all, it is still a sum, so when we write it in an expanded term, we are saying that it's equals to this entire sum. So please remember to include the bracket. Okay, and also, because it is still a sum, please ensure that there is the plus sign at the start of every row. Okay, so that will be the key points to note for method of difference. This concludes my lecture, method of difference, and the next lecture we will follow up with section 3.4, which is for applying given formula.